Ideal gas law, page 10. So, first of all, ideal gas law. So, we should give you a definition of what it is, and it's this. PV equals nRT. Some people call this the Puvner equation instead of the ideal gas law. Puvner. So one of the things that my students really struggle with, I want to make sure I say out loud first, is, how do you know if it's the ideal gas law or is it, Boyle's, Charles, Gay-Lussac, or combined, right? How do you know when to use this law versus these? And here's what I would tell you. For Boyle's, Charles, Gay-Lussac's, and combined laws, like Boyle's law is P1 V1 equals P2 V2, right? So you have two pressures and two volumes, and usually you're solving for one of them, right? But you're given three of these four things. Charles' law, again, you're given a volume, you're given a temperature, maybe you're asked the volume and given another temperature. But again, it's 2 and 2. Pressure. So, Gay-Lussac's law. But again, it's two pressures and two temperatures. Puvner here, one pressure, one volume, one temperature. So that's the indicator for me that I don't use these laws. Is if I only give you one pressure, one temperature, 1 moles, etc., and then ask you for the volume, well, I didn't give you two of them, right? So it's not like you can use any of these laws. And that's how I know to use Puvner versus these things. Okay? Now, what does PV equals nRT stands for? It means the following things. P stands for pressure. The units that pressure must be in is ATMs. It absolutely has to be in ATMs here. I'll tell you why in just a second. V stands for volume, and it must be in liters. M stands for moles of gas. Now, sometimes this is given to you in grams, and you got to convert it into moles using the flux capacitor stoichiometry, and then find the moles. Which brings us to this thing, R. R is a constant, just like the speed of light, c, right? C was 3.00 times 10 to the 8. Or, you had Planck's constant, 6.626 times 10 to the negative 34th, right? Well, here, R is this exact number, 0.08205. It is a constant. It is always 0.08205, and here's the units. Liters, ATMs. That corresponds to here. ATMs corresponds to here. That's why this has to be an ATM. That's why this has to be in liters. Liters, ATMs per mole Kelvin. Moles. And this is moles right here, right? And then when you look at this, obviously the last thing then, temperature has to be in. So this is temperature. And it has to be in Kelvin. So we can use this 0.08205 liters ATMs per mole Kelvin. That's why it has to be that way. So we have a question, number 1. It's on page 10, and I'd like to go through it. It says, how many moles of gas? So we're going to solve this for N. How many moles of gas does it take to occupy 120 liters? So you're going to plug that in for V. At a pressure of 2.3 atmospheres, you're going to plug that in there. And a temperature of 340 Kelvin. Well, let's plug it in and go. So, pressure was 2.3 ATMs. I asked myself, is that okay? Yep, ATMs is going to match ATMs. Then, we had a volume that was given to you, and that volume was 120.00 liters. Again, that matches this right here, so boom, we're good. So, PV equals, we're solving for moles of gas, so it's N, times 0.08205 liters ATMs per mole Kelvin, times temperature. that temperature has to be in Kelvin, and the problem, it's given to you in Kelvin, 340 K. Okay, so I do the math on this, and I get N equals, right? I multiply these two things, divide by this. In order to isolate the N, you know how to do algebra, hopefully. So when I did this, I get 9.89 something. Well, when I look at this, 2 sig figs, 5 sig figs, 4 sig figs, 2 sig figs. Therefore, your answer can only have 2 significant figures. 9.89 is not acceptable. 9.9. The label is moles. That's number 1. Let's do number 2 together. Number 2. Number 2 says, if I have a 50-liter container holding 45.0 moles of gas at a temperature of 200 Celsius, what is the pressure inside the container? So we want to know P. When the volume is 50.0 liters. And that's equivalent to 45.0 moles times 0.08205 liters ATMs per mole Kelvin times the temperature has to be in Kelvin. Well, it's not here. 200 degrees Celsius becomes 473.15 Kelvin. You do the math, you multiply these three things, you divide it by 50 to isolate the P, you get P equals 3 sig figs, 3 sig figs, 4 sig figs, 5 sig figs, therefore your answer can have 3 due to these two numbers. So when you round it, you get 34.9. Because of ATMs here, remember liters has to match liters, moles has to match moles, Kelvin has to match Kelvin, therefore the pressure has to be in ATMs. I'm going to tell you, as you can do more problems, you are going to notice where you are going to have to make some conversions. Where I'll give you the pressure in, torr, and you're going to have to convert it into ATMs so that you can use this 0.08205. Again, must be ATMs, must be liters, must be moles, must be Kelvin. And that's the ideal gas law.